Welcome back. In this episode, we'll be talking about the Pandas data analysis library. Now, this is a library that is designed to help us do a lot of data cleaning and analysis, and it's very similar to the R programming language because the data structures are called data frames in series, and this will really help us quickly do some interesting analyses. So if we look at the actual code, we can get into what we can do with Pandas series. Now, in order to actually use it, we have to import it. And we already saw this with the Natural Language Toolkit and the regular expression library. But what's very standard with Pandas is to import it with an alias, and that alias is generally PD. And this will just make it a lot easier for us to quickly use the Pandas library, so we can type pd.themodule name instead of pandas.themodule name. So it's a handy thing to do, and PD is conventional. Now, in this particular piece of code, we're only going to be using series, so we'll go ahead and import just the series module from the Pandas library using from pandas import series. Now, we'll also import NLTK because we'll do some basic text analysis just using these series. Now, series are really handy because they're quite similar to lists, but they come with a lot of extra functions. And it's very easy to turn a list into a series. So for example, if I have this number list, which is just the integers 1 to 8, I can turn this into a series by just giving the series function the number list. So series, parentheses, number list, close parentheses, and I'll save this as my series, and we'll print this so in a second we can see what this actually looks like. Now we can use built-in functions of series to do some really basic text analysis. So we've seen code like this a few times in this course, where we're opening a text file, we're reading it to a string, and then we're closing the text file. And then we're just going to go ahead and tokenize this string into individual words. Now, because this is just a list of words, we can turn this into a series really easily by giving this list of words into this series function. And I'll save this as my word series just because that's a handy variable name. Then, if I want to just get the value counts of all of the words in this text, instead of writing out that relatively complicated piece of code that we talked about a few episodes ago, I can just use the series value counts method. So I have this word series, and then I'm just going to call dot value underscore counts, open parentheses, close parentheses. And I'll save this as word counts. Now this is another series, except instead of just being those words, it's going to be the words and how often they occur in the document. And we can actually apply functions to all elements in series really easily. So for example, I can take my word series and make everything lowercase by just doing word series.str.lower. So I'm just calling this string lower function. And I'm saving this as lower series. And we'll go ahead and do a value counts with this too to see what the difference between the two is. So let's go over and look at our code. So Python, this is 19 pandas 1 series 1, and I'll run this. And the first time you run this, it might be a little slow because it has to load in pandas into the namespace, and it's a little heavy duty, but really not too bad. So if we go up and we look at that first list, which is right here, we can see that it is 1, 2, 3, 4, 5, 6, 7, 8. But the handy thing is this series comes with an index, and it's going to print out the index right next to the values themselves. Now the cool thing about series is they don't just take integers as an index. You can also use words or other immutable data types. So you could use a tuple or something else like that. But here we can see they're strings. And if we look at our word count series, it's comma 7,779. And this is just the frequency of how many commas are in this document. And you can see the is 5,420, I is 2,990. So what it's done is it's taken that word series and returned another series that's just the frequency of every value in the series. And here it's already in organized order, which is a really handy thing. Now if we go down and we look at our lowercase series, we can see that it looks exactly the same, but our counts are a little bit different because now we're treating the with a capital T the same as the with a lowercase t. So this is a really handy thing to know how to do. But we can do a lot more with our series if we want to. So let's move on and talk about the next thing that I want to talk about here, which is going a little bit further with this word count series. So here I'm just importing everything right at the top. And let's go ahead and get back to where we have that word count series. So now we have word counts saved into a series. Now we can actually extract extra information from this pretty easily. So unlike lists, indices for series can be words and other different types of things like I just mentioned. But unlike dictionaries, which have these other types of keys, series are ordered. It has an actual index rather than a key map, essentially. So you can actually get data out pretty easily by using the index name. And this, you'll notice this looks very much like a dictionary call. So our word count series, we're just going to insert the string Holmes, and this will get out how often the word Holmes occurs in this series. You'll also notice up here in line 11, I am going ahead and cleaning this word list before I give it here. This is not something we did a second ago, but we've seen it in earlier examples. Now you can also get a value out by its index number, even if we have a word index. So for example, we can get the most common word by just looking at the item at the 0th index in this word count series. And I'll go ahead and print out the most common words common word occurs the num times. You can also get, you can use a get method to extract a value. The nice thing about this is that it will return none if the value you're trying to search for doesn't actually exist. And this is very handy if you're trying to avoid errors and you don't want to deal with try and except clauses. So here, I'm just saying print wordcounts.getChimp, and this is a word that I know doesn't actually occur in this text, and we'll see that it just returns none. Now, one quick comment about series and pandas in general. If you're interested in the R programming language, which I really encourage you to get into, because a lot of digital humanities scholars use it, and there's a robust community that has done some remarkable research with it. And it has very good plotting libraries too. But Pandas actually mimics R in a lot of ways, and it treats everything as a vector, and it does vectorized computation, so it will essentially apply things in parallel. So if I want to say multiply my series times 2, what this is going to do is it's going to find whatever value is in the series, and it's just going to double it for each element. If I want to add them together, word counts plus word counts, it's going to match it up along those indices and return the added values. If I do word counts minus word counts, well, what you would expect is then a series just of zeros. And we'll go ahead and we'll run this Python 19 pandas 1 series 2, and we can see that that's exactly what happens. So if we go up here, we can see that the index of this series object is the and I of, so on and so forth, all the way up to upbraided vacantly. Now, unlike the natural language toolkit, this doesn't have some of the more linguistic-based methods, but it does have a lot of basic, more general data methods. So we couldn't just say, give me all of the words that occur just once. We would have to look at the actual values to do that. It wouldn't be difficult, though. We can see that the word Holmes occurs 466 times, and that the most common word occurs 5,793 times. We can also see that when I looked for chimp, it returned a none right here. And here we have our doubled series, which is just this is 5,793 times 2. You can see that every number in this series is just doubled. And then here, when we add them together, again, it's just doubled. And when we subtract them, we have a series of all zeros. Now, series are really useful, but if you work at all with complicated data or even spreadsheets, you'll want to know how to actually deal with spreadsheet-like data in Python. And Pandas has a really nice way of doing that. And we'll move on to the second really important component of Pandas, which is the data frame. Data frames are really useful objects that are essentially like series, except they're in 2 dimensions. So instead of having a single column, they can have 1, 2, 3, 4, up to infinity is an exaggeration, but it can have a lot of columns. You can think of it just like a spreadsheet, as I said a moment ago. Now, if you want a quick intro to Python, or excuse me, Pandas in general, I encourage you to check out this link. It'll give you it's a handy reference guide to help you do all sorts of things with this. But I'll go ahead and start off by importing pandas as PD, like we saw last time. And I'm importing the NumPy library, which is the numbers Python library, just so I can generate some dummy data for our data frame. And I'll import from pandas the data frame object. So to create a data frame, what you need to use is you need to use data frame, open parentheses, close parentheses. And inside these parentheses, you're going to give it the data that's going to be used to actually construct the data frame. And here what I'm doing is I'm just using NumPy to generate a matrix of data. And in this particular case, I'm getting a random number that is normally distributed around 0, and I'm getting 10 rows of 5 columns. And I'm just giving the columns, I'm naming them A, B, C, D, and E. And I'll print this off so you can see what this data frame looks like. Now, essentially each column, very interestingly, is a series. So you can think of a data frame as just a bunch of series stacked together. I'll go ahead and I'll run this code, Python Pandas 19, Pandas 2, data frame 1. And I'll run this, and you can see that we in fact do have 10 rows of 5 columns. And you can see that we have this index just like we had with the series, but now we also have these column names. And we can actually use these column names to extract a column from the data frame. And here I just extracted the A column, and we can see that it gives us 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as the indices, and then the values as the columns. So this is essentially just a series. If we look at the next piece of code, we can push this a little bit further to start doing some more interesting things. Because these data frames handle 2-dimensional data, we can use them to analyze actual spreadsheets. Now, you might be familiar with Excel, which is one of the most common spreadsheet software, pieces of software. But we're going to be using not Excel files, but CSV files or TSV files. These are plain text files where the columns are delimited with some character. In a CSV's case, this is a comma. In a TSV case, this is a tab. And if you only have Excel files, you can use Excel to export as CSV or TSV. So it's really easy to get information out of Excel and into Python. Now, to import our data, we're going to be using the read CSV method. But I should point out that you can use this same method to open TSVs. You just have to tell it what your actual separator is when you call the function. We'll see that here in a second. But I'm going to just go ahead and load in a little bit of data about the Netherlands and its weather history. And I got this data from the National Oceanic and Aeronautics Administration, or National Oceanic and Atmospheric Administration, excuse me, from the United States government. It's public domain data, and it's nicely structured, and we can load it in and do a little bit of basic analysis. So here we're just going to load this in. You'll notice I have the name of the file, and I have the separator set to a comma. This is because it's a CSV. To use tab characters, I would use a backslash and a T. But here we're just using commas, so that's fine. And I'll print this data frame so you can see what that looks like. I can get the index out of it. I can get the columns out of it. But I should point out that in df.index and df.columns, you'll notice that there are no parentheses here. And this is a little bit different than a lot of what we've seen in the past. And this is because the index and the columns are attributes, and they're not methods. So we're not calling a method to get the index. We're just looking directly at the index. So this is an important distinction. One of the other very useful things that we can do with data frames is get just the top of it. This is handy to make sure that the data that you're loading in looks like what you're expecting. And you just use dataframe.head. So this is your data frame, which I'm calling df. And if you want to see the first 10 rows, you can say df.head and then put a 10 inside these parentheses. So let's go ahead and run this data. And this is data frame 2. we can see what this spreadsheet actually looks like. We can see that it has an index for the rows from 0 all the way up to 228,548. And it has these different columns: station, name, date. These dots represent information that's just left out for this preview. And then we have temperature average, maximum and minimum. You'll see all these not a numbers, but we'll deal with that here in a second. We can also see we printed out the index, which is just these numbers, 0 to 228,000. And then we have the columns here: station, name, so on and so forth. You can see that it even tells us what our data type is. Here it's an object. Sometimes it'll be strings or integers. And then when we print out the head, by default, it just prints out the first 5 rows. And we can see the station identifiers, the town names, the dates, and then again, this not a number. So we'll clear this off, and let's talk about the next piece of code. And we're actually going to clean this up a little bit further and do some analysis with it. And data frames really make statistical analysis quite easy. So here we're again importing everything as we saw before, and we're going to go ahead and load in our data as this data frame. And to get some basic statistics, we can use this df.describe method. And what this is going to do is this is going to give us maximum values, minimum values, means, standard standard deviation of any column that has numeric values in it. We'll see this in a second. Now you'll notice all of those not a numbers that we saw a second ago. Often we'll want to just dump these. If we want to dump every row that contains any not a number value, we can use this drop NA method, and this will just erase those rows from our data frame. Now, if you wanted to drop columns instead of rows that contain any not a number, you can use drop NA, and then inside those parentheses put axis equals 1. You can also say axis equals 1, how equals all, and in this case it will only drop a column if all of the values are not a number. Otherwise it'll drop it if even a single one is not a number. And of course you could get rid of this axis 1 to run this on the rows as well. You can use a lot of other very handy descriptive methods. For example, df.max will give you the maximum value of every column. df.min and df.mean will behave exactly as you might expect, finding the minimum and mean values. We'll go ahead and we'll run this Python 19, pandas 2, data frame 3. And we can see that that first call that we had was the describe call. And we can see that it gets a count. So how many times, for example, how many values are found, for example, in the PRCP column? This is precipitation. We can see that a lot of these rows had that information. The tmin gives us the temperature minimum, and then it gives us information about mean, standard deviation, minimum, and then it gives us the quartile and the max value. Here, when we get the maximum values, we can say, for every column, what is the maximum value? So the station, it's this NLM, all these zeros, 6380. This is kind of meaningless because that's just an ID code. For names, it'll give you alphabetically the last name. Dates, it'll give you the most recent date. You can see that this goes all the way up to May of 2018. The highest precipitation is 40.5. This is the speed of the wind, I believe. And then the highest temperature, or excuse me, the highest average temperature was 24.6. The highest maximum temperature is 31.9. You'll notice this doesn't include the most recent heat wave when it got up to almost 37. And then the temperature minimum, which is 20.9. So this is a really handy way to quickly get historical weather data. Now this is not humanities data, but it is numeric data, and this is a very handy way to kind of explore some of these features. So if we go back and look at the next piece of code, we can see that there are ways of getting specific pieces of information out of this data frame, and it looks a little bit different than what we've seen in the past. So for example, if we want to get the very first row of our data, we want to use df, and then inside these square brackets, 0:1. Essentially, we're taking a slice of this data frame. Now df0 won't work because the data frame doesn't know how to handle that. If we want the first 5 rows, we can do 0:5. This is exactly like getting slices out of lists. We can also get unique values if we want. So we can say, let's go into the name column here and say, give me all of the unique values from that name column, and then just print out the first 10. And I'll go ahead and run this code, Python 19 pandas 2 data frame 4. We'll run this, and we'll see that it shows us the first row, it shows us the first 5 rows, and it gives us the first 10 values in the unique place names. So this will just quickly tell you all of the different stations that we have information about. So if we go back to our code and look at the next piece, we can start talking a little bit about how we can clean data that comes in a spreadsheet. Because when you get information from the real world, you'll often find that it is just very, very messy and it almost always requires a little bit of cleaning. So we'll start to talk now about how to filter a data frame to get specific information out of it. So here I'm just loading in the data into a data frame. And the first thing I might want to do is I might want to just get rid of all of the rows that don't have temperature data. I might want to include some that don't have the temperature average for that day. But here what I can do is I can actually do some interesting Boolean operations on these data frames. So we have this data frame, and we have this kind of strange looking code here. We can say, from this data frame, let's get a slice of data. But we can give a Boolean expression here where we can say df, and then inside square brackets, tmax. So right here we're saying, give me this column tmax. And on that column, we want to say dot not null parentheses. So what this will do is this will go into that column and find all of the rows where tmax isn't null. And this returns what's known as a Boolean data frame. And if we feed that into another set of square brackets here, it will only give us rows from that data frame where tmax is not null. Now, is null is also a thing, so if we wanted to get rid of all of the rows that actually have a temperature value, we could do that. And then I'll do this again for the tmin column. I know this looks a little weird, but it's actually a really cool thing, because by feeding in these Boolean expressions into these square brackets, we can get the data that we want out. We could use this same concept to get all of the observation where the temperature is above 28 degrees. So here I'm again calling that column tmax, and then I'm just saying is greater than 28. And I'll feed this back into here, and it will just give me a data frame with only temperatures where the temperature maximum is above 28. I could do a similar thing if I wanted to get all of the observations from a particular place. We haven't seen this convention quite yet, but we can do df, which is our data frame variable name. Now remember, we named this variable, so it could be anything we wanted. But here we say df.name, and so here, right here is the name of a column. So df.name equals Rotterdam, Netherlands. And so I'm saving this as another data frame called rot, and then I'll just print out rot.describe, which will give me some basic information about the weather in Rotterdam. Now here, this is exactly the same as if I did this, where the name equals Rotterdam. But this is just another way that you can get information. So I'll go ahead and I'll run this, clear that off, Python 19 pandas 2 data frame 5. And we can see now that we have a few different data frames that I've printed out. The first is just the data frame with only the rows that have, both maximum and minimum temperatures for that particular day, because not all weather stations deliver this information. And then after that, I have a data frame where the temperatures are only above 28 degrees. And we can see that this happened in Twente a lot, Westdorp, Eindhoven, and so on and so forth. But we can see that actually there's not nearly as many days when this happened. Only 581 days only 581 observations, I should say, because many of these happen on the same day in different places. And if we want information about the weather in Rotterdam, we got that Rotterdam column and then just ran describe on it. We can see that there were 672 observations in Rotterdam from 2016 to 2018 in a specific set of dates that I downloaded. We can see that on average, there was 2.46 millimeters of rain. We can see that the average maximum temperature was about 14.5 degrees, and the average low was 6.5. The highest it got up to May of 2018 was 32.4 degrees. So you can see that this gives us a lot of options for getting specific information. But we can do more. And this is one of the cool things about Pandas. If we look at the next piece of code, we can fill this data frame out and do more with it. So if you notice that t-average column had not a number, well, because we have the t-maximum and t-minimum, we can really easily get the average for every single day. And notice we don't need a loop to do this. So we've loaded this in and we've cleaned it up. Now what we can do is we can just say, give me a data frame and a list of different columns. So from that data frame, I want the tmax and the tmin. And then what I can do is I can just say .mean. And this one is just telling it to average it between the two rows and not in the column. And then I'll do this, and I'm going to assign that back to this t-average column. And we'll go ahead and I'll run this. 19, 2, 6. And we can see that instead of not a number, now we actually have that average value for every single day in our data set. So we can use this to really fill out a lot of information and clean it up. The last thing I want to talk about when it comes to Pandas is how we can use this to do a little bit of basic plotting. And we'll get more into plotting here in a few episodes. But you can plot this data by loading in the matplotlib library, and we'll see this a lot. But for now, let's just accept that we need to do this. Matplotlib.pyplot as plt, and you can see a little bit of a description here about what that is. And I'm loading this data in. I'm going to clean it up. I'm going to fill out the t-average. And then what I'm going to do is I'm going to convert the date column to a Pandas date type. And the reason I'm going to do this is because Pandas has some extra features when it comes to dates that will help us plot out time series. So what I'm going to do is I'm going to use this toDateTime method, and I'm going to give it the df date column, and then I'm going to save it back to df date. So I'm overwriting it with, instead of just having a string that has a date in it, I'm going to use an actual Pandas datetime object. So let's plot the maximum temperature in Rotterdam across our entire data set, just to see what that looks like. So we'll set the date as an index. So here you can say Rotterdam.setIndexDate. Here I'm giving it a column name. And this way, it's going to label this plot for us in a nice fancy way. And we'll go ahead and we'll plot out the maximum temperatures. And then we're going to call plt.show. There's a lot of work going on in the background with matplotlib. We'll see more of this in a little bit, but to actually see anything, we need this last call. So here we're going to clear this Python 19, 2, and 7. So when we run this, it will open up a new window that looks like this. And the nice thing about this is it will automatically resize for us, and we can see the temperature in Rotterdam from September of 2016 all the way up until June of 2018. In fact, it's like May 20th of 2018. So we can see summer, summer, winter, winter, and we can use this, and now we can actually generate all of these different tables that show us information about climate data. Now that's not humanities data, but we'll see a lot of information in the course of our class where we might want to use Pandas to do plotting that's a little bit similar. For example, if we want to plot how many novels were published in a given year in a particular place. We can use this to do something like that. So in the next episode, I'm going to be talking about how to actually represent a corpus in a meaningful way. And we'll use all of the different things we've been looking at in this class up to this point. So I hope you'll join me in the next episode, and I'll see you soon.